So in this video, I want to go over the file hd1.py for coming up with a basic kind of solution for the Home Depot Kaggle challenge. So first of all, let me show you the data, which you can download from kaggle.com if you register for the Home Depot challenge. So here's the data in train.csv, so you can read it with Calc or Excel or something like that. A CSV file stands for comma separated files, so if you just read it with something like gedit, for example, you can just look at what that looks like. It's comma separated values like that. So here it is in Calc though. So the way it looks is you have this kind of table with the line ID, you have the product ID, you have the product title, you have the search to which this is the result, and you have the relevance, which was manually annotated, the relevance of this product to this search term. You also have all sorts of data about the different products. So in particular, in product descriptions, you have takes a little bit to load. So here it is. So you have product ID, and then you have a textual description of the product. And that's what you have in this file, product descriptions.csv. So the first thing I want to do is I want to show you how to read in those CSV files. So here I am. So what you need to do in order to read in the files is to import pandas. So you can either install pandas separately, or you can download the Anaconda Python distribution, and just use that. You also need to import NumPy, which again is available with Anaconda, also other distributions as well. So okay, so assuming we did all that, and here I'm just changing the current directory to the directory where I'm storing all my data files. So here we are. So you can read in all of those files with read CSV, which is imported from pandas. So let's do that and let's see what we get. So it takes just a short little while. Here we are. So now train, for example, which you read in here, if you look at its value, so that prints out as a table. You can also print out just the first few lines of train using LOC like that. So I want, for example, everything up to 5. And here we are, we have all the lines up to 5. I can also get individual columns by going train at, for example, search term, and that'll give me a column of all the search terms. It doesn't print everything out, but you see that here the first 6 correspond to those guys, so you can access them like that. So okay, so the first thing that we want to do is we want to somehow use not just the product title, but also the product description in our prediction of the relevance. So how to do that? So we have another table which we read in over here when we read the product descriptions. So we have this table which we call desks. We can look at it. So here it is, and it has product ID corresponding to product descriptions, right? So now what we can do is we can actually merge the table train with the table desks in such a way that on each line we'll have the product description available as well. So let's do that. So here's how you do it. Let's create a new table, let's say T1, and it's going to be equal to train.merge, and then we'll say product descriptions, desks, sorry, and we want to merge it on, I believe it's product UID. Yes, so we'll take this product UID and we'll merge on that. So what's T1 now? Here is T1. Let's look at the first 5 rows, for 6 rows of T1. So you see it now also has product description. So what it did is it took the table train, which looked like this, right? And then it said, okay, so I'll look up in the table desks, I'll look up the line with this product ID, and I'll also add the product title. And that's also add, the product description from desks. Okay, so this is how we have the merged table. And again, looks like this. So now we have the product description as well. So, okay. And this is exactly what I did here. So I merged train with desks on product UID. And that's the result. I did the same for the test. So how do we actually do the prediction? So here's the idea. The idea is this. So let's say that we have this kind of table that looks kind of like T1, right? And what we want to do is we want to look at all the data in a single line of T1, and maybe we want to extract some more data from that line, and we want to somehow predict the relevance. So that's what we want to do, and this is just one way to predict the relevance, but we want to do something like relevance equals to A0 plus A1 F1 plus A2 F2 plus and so on plus AK FK. And each of the A's are just real numbers, which we want to find the best real numbers that work the best for us for predicting relevance. And F1, F2, and so on up to Fk, this is data that's extracted about the search query and the product. Okay, so what you might say is, for example, F1 might be something like the number of words that are in the intersection of the title of the product and the search query. So you might imagine that if F1 is larger, then the relevance becomes larger. So that would mean that A1 is going to be some kind of positive number. And you might imagine that F2, you might imagine something like silly, like, the length of the search query, for example. Why would that be interesting? Well, it might be that if the search query is longer, you get better results, that the relevance goes up, right? So the task, in a way, in this challenge, is to come up with good Fs. And then there is a way, which I'll show you in this video, to find those coefficients A in such a way that this predicts the relevance the best. So before we can get to that, we need to rearrange our data into a matrix. So what I mean by a matrix is this. So we have multiple query product matches. And what we want is we want to basically arrange all the Fs for each match in a matrix. So it's going to be kind of like this. The matrix is going to look like this. So for the first line, we'll record F1, 1, and then F2, 1, and then F3, 1, and so on. And then for the second pair of search query and product, we'll also compute F1, 2, and then F2, 2. So this index is for the pair, right? And this is just F1, F2. That's the same for everything. And that's going to be F3, 2, and so on, right? So what we want is we want to just arrange the data into this kind of matrix. And then we also want just a vector of all the relevances. So we want relevance 1, and then relevance 2, and then relevance 3, and so on. So we want this kind of vector of the correct answers, which we're trying to predict. So we're trying to find the best A's such that A0 plus A1 times this, A2 times this, A3 times this approximates this. And then we also want A0 plus A1 times this plus a2 times this, and so on, to approximate this as best we can. Okay, so that's the task. So this is what we're going to do. So in order to do that, what I'll do is I'll first initialize those matrices to be just zeros. So I'll show you which f's I'm computing in a second. I'm going to be computing 6 f's in total, which is why I want to create a matrix that's of length the number of pairs by 6. So the number of pairs going like this, by 6 going like this, because I have 6 f's for each pair of query and product title. So if I want to create a matrix that's all zeros, here's how I can do it with NumPy. So that requires that I import everything from NumPy, like so. So if I want, for example, 5 by 2, this is going to be the matrix. I can operate on it like that. So here's my matrix M. I can change it, for example, by saying M at 3 at 0. And that's going to be the M30's coordinate. Let's say that I want to set it to 42. Here it is, set to 42. Okay. So here what I'm doing is I'm creating a matrix that's the length of the train table in height by 6. Here I'm dividing by skip because what I want to do sometimes in order to speed up the process is I want to only take every 10th line in the train table. Okay. So all that I'm doing here is I'm computing my features, computing my f's, and putting them in my matrix train learn x. This would be this matrix. And in the vector train learn y, which would be this matrix. Okay, so you can look through it. There is nothing much to it. All right, okay. So now what I want to do is I want to find the best a's in such a way that they approximate the relevance the best for the data that I've stored in my train learn x, train learn y. So this is how I do it. What I want to use for it is linear model that I import from sklearn. Again, sklearn available with the Anaconda Python distribution. Okay. So what I want to use is I want to use the ridge class from linear model. What this says is that I want to find there it is. So what I want to do is I want to find the A0, A1, A2, and so on up to AK in such a way that they minimize the sum of the square differences between the true value, this would be the relevance here for line I, and the approximation squared. Right? So that's the basic thing. And also, in addition to having this sum, I also want to add alpha, the alpha is this guy, times the magnitude of the vector A, that's not including A0, squared. And sometimes it's useful. In this context, it doesn't actually change much. I'm just setting alpha to be pretty small here. Okay. So let's say that I do that. So now what I want to do is I want to actually compute all the f's. So let me do that. Let me run my thing in order to compute all the f's. Here we are. Okay. So once I've computed all the f's, what I can do is I can say, okay, I'll first set up my ridge linear regression. Then I'll fit it. Fit means find the best a's. Now I can look at what the coefficients are. In order to do that, I need to execute this line. So this would be the A0. So 2.42 is the A0. And then it's going to be 6 times F1 plus 0.02 times F2, 0.04 times F3, 0.03, and so on. Okay. So what were my F1, F2, F3, and so on? So here they are computed. So F1 was the cosine similarity between the search terms and the product title. So that was pretty high. That was the most important feature. The cosine similarity between the search term and the product description, positive number, but a very small positive number. The overlap, so the number of words in common between the search term and the product title, again positive but small. Overlap between the search terms and the description, pretty small. The last thing is, I skipped over one of them, I'm not sure which one. The last thing is other brand present. Other brand present means that in the search query we have a brand which is not actually the brand of the product. And you see that that has a small negative influence on the predicted relevance. So okay, so those are the best A's. Now what we can do is we can use this thing in order to actually predict what the relevance is going to be. Now, as it happens, we know what the relevance is. That's train learn y, but let's pretend that we don't know, and let's just compute the sum a0 plus a1 of 1 and so on. So those are going to be the predictions. Those are the true values that we read from train.csv. And what we can do now is we can compute the measure of how much they differ, and it's going to be the mean square difference, and then take the square root of that. So what do we get? We get about 0.509. Now here I'm computing the baseline, which is the prediction minus just the straight average of all the relevances. So what's that going to be? That's going to be 0.53. Okay, that's it.